Alright, so let's say you're given this diagram of a descending elevator, and the question says, an elevator of mass 100 kilograms is moving downward at 10 meters per second. It slows down with a constant acceleration and stops at 25 meters. Find the tension of the supporting cable while it is slowing down to rest. Would you know how to solve? If not, continue watching this video. So we can start off by drawing a free body diagram for the elevator of mass 100 kilograms. The two forces that are going to be acting on this object is going to be the weight force, bringing it down, and the tension force from the cable. These are the only two forces acting on the elevator. To solve, we're going to need to use Newton's second law, which is the summation of forces equal to mass times acceleration. Since the elevator is only moving in the vertical direction, transfer that into the y component equation, which is given below. So if we look at our free body diagram, we have two forces, tension and the weight. To find the positive y is up, it's going to be tension minus weight. If we plug that in, we get this expression here. And then if we remember that weight is equal to mass times gravity, we can substitute that and then bring it to the other side. We know we have two unknowns here, the tension and the acceleration in the y. We're going to need to use kinematics to solve for the acceleration in the y. We can start off by writing down this kinematics equation here. This is going to be the one that we're going to use to solve. And we can identify all these unknown variables from the question. The question says it's initially moving 10 meters per second down. That's going to be the initial velocity. And then it stops at 25 meters. That's going to be the y final. You can write this down here. Vy initial is going to be negative 10 meters per second. That's because the elevator is moving down. It's going to be in the negative y direction from what we defined. We can define the final y as 25 meters as we said before. Assume that the initial height is 0 meters. We plug all this in. We also have to note that the final velocity is equal to 0 since the elevator comes to rest at y equals 25 meters. So if we plug all this in, we get this expression here. Simple computations, we can compute the left term here, which is just going to be negative 10 squared is 20, then meters per second squared is meters squared second squared. And then we can also compute the right term, which is just 2 times 25 meters, we get 50 meters. Plug all this in, and then we can bring the 20 meters squared second squared to the other side, and it becomes negative. And then we can multiply the whole thing by 1 over 50 meters. Another simple division. Make sure to divide the units and divide the amplitudes. Get this for the final answer for the acceleration. This makes sense because if we look at our diagram here, for the elevator to stop, the acceleration must oppose the direction of motion, which it does. Therefore, the elevator is decelerating. Plug this back into our Newton's second law equation in the y direction. Now we can plug in all our unknown values and we get this. We can just compute the left term and the right term, the amplitudes in units, and we add those two together. We get this for the final answer for the tension force. This is going to be the tension felt in the rope while the elevator is decelerating. Draw our diagram here. We have our acceleration pointing in the up direction, allowing it to slow down. And then we have our tension force felt in the cable while it's slowing down.